Let's take a look at this worksheet that has this stoichiometry map on the front of it. We're talking about gas stoichiometry here. I've created a new version of that for this video. And let's take a look at question number 2. And here it is. Question number 2 says, acetylene gas, C2H2, reacts with oxygen to produce carbon dioxide and water vapor. And so what is acetylene gas? Acetylene gas is C2H2. And that's what we're looking for. It says, how many liters of C2H2 are required? And so what do we know by reading the given? We know that there are 75.0 liters of CO2. So it's important to know that this is where we're starting. We're starting with 75.0 liters of CO2. And so now we know where we're starting from, and we also know where we're headed. And therefore, we need to try to figure out what parts of the map will help us with that. So we're given liters of gas. And what we're going to do in the first step is we're going to use GMV to convert liters to moles. So we're going to use this part of the map. And then we're going to take the moles of that and use the mole ratio from the balance equation to find the moles of what we're looking for. And since we're trying to get to liters of gas, then we can just use the GMV again to convert that number of moles to liters of gas. So let's try it. The given is 75.0 liters of CO2 gas. And what goes on the bottom is liters of CO2 gas, because we put on the bottom what we're trying to cancel out. And since we're going from liters of gas to moles here, we're going to put moles of that substance, CO2, on the top. And now we realize that we're going to use the GMV, which says that 1 mole of any gas, in this case CO2, is 22.4 liters. And now we use our calculator. We multiply by the top and divide by the bottom. 75.0 times 1 divided by 22.4 gives us a numerical answer of 3.35, but more importantly, this gives us moles of carbon dioxide, because liters have now canceled out. Step 1 completed. Now that we know the moles of CO2, we're going to use that answer, 3.35 moles of CO2, and we're going to convert that from moles of CO2 by writing those units on the bottom. And what are we looking for? We are looking for the moles of C2H2 acetylene. And where do we find the numbers for this kind of a conversion? We use the mole ratio, the coefficients of the balance equation. And the coefficient of CO2 is 2. And the coefficient of acetylene is 1. And now the moles of CO2 cancel out, and we're left with moles of acetylene, C2H2. And remember, multiply the top and divide by the bottom. And if we use our calculator, we find that that's 1.68, but more importantly, units, moles of C2H2 acetylene gas. Step 2 completed. And now we're going to use that answer, the moles of what we're looking for, 1.68 moles of C2H2. And we're going to put those units on the bottom of this final conversion so that we can cancel those units out. And we're going to put liters, because we're trying to find the liters. This is how many liters of C2H2. And we'll realize that this is, again, the GMV, because it's the relationship between moles of a gas and liters of a gas. We know that 1 mole of any gas is 22.4 liters of that gas. In this case, C2H2. The moles of C2H2 cancel out, and liters remain. And so therefore, this is going to be liters of C2H2. And if you use your calculator, multiply by the top and divide by the bottom, the final answer is 37.6, but more importantly, liters of C2H2 are required. All 3 steps are needed. And just to summarize, what were those steps? Step 1 is to convert from liters of gas to moles of that gas. Next, moles of that gas to moles of what we're looking for. And then final step, moles of what we're looking for to liters of what we're looking for. That's question number 2. A. Now let's try question 2B. In question 2B, we use the same given. Given that we have 75 liters of CO2. It's important to know where we're starting from. 75.0 liters of CO2. But look at what the question is now. What volume in liters of H2O is produced? In other words, this is what we are looking for this time. So now we know our starting point and what we're looking for. And the steps are similar, just like in 2A. We know the liters of gas. We're starting with 75.0 liters of CO2. We're going to use the GMV to convert those liters to moles of CO2 in step 1. In step 2, we're going to convert moles of CO2 to moles of what we're looking for. In this case, we're looking for moles of water. And once we know the moles of water, we can convert it to liters of water in the 3rd step, again using the gas molar volume. And so let's work on that. The given is 75.0 liters of CO2. And again, we put on the bottom the unit what we're trying to cancel out, in this case, liters of CO2. And on the top, we put the units of what we're looking for in this step. Remember, this is liters to moles. Liters to moles. And we realize that that's the relationship between moles and liters. 1 mole of any gas is 22.4 liters. That's called the gas molar volume, or GMV. Liters of CO2 cancel out, and we have moles of CO2 remaining. Multiply by the top, divide by the bottom. Our 3-digit answer is the same as the first time, 3.35 moles of CO2. Step 1 complete. We'll use that answer, 3.35 moles of CO2, and convert from moles of CO2. That's why we put that on the bottom of the conversion. And this time we are looking for water. So we're going to put moles of water on the top this time. And when we do that, we find out that we need to use the mole ratio because we're converting from moles of what we know to moles of what we're looking for. And where do we get the mole ratio? Get those from the coefficients of the balanced equation. Knowing that 6 moles of H2O, see the 6, is produced for every 2 moles of CO2. That 2 right here. And now the moles of CO2 cancel out, and we're left with moles of H2O. And if we use a calculator, 3.35 multiplied by 6 divided by 2 gives us a 3-digit answer of 10.0 moles of H2O. There's an intentional 0 there, so we have 3 digits. Step 2 complete. And in the final step, we take those moles, 10.0 moles of H2O, and we convert those by putting moles of H2O on the bottom, because that's what we're trying to cancel out in this step, to liters of H2O, because now this is a gas. And we can convert moles of gas to liters of gas using the GMV, knowing that 1 mole of any gas is 22.4 liters of that gas under standard conditions. And moles of H2O cancel out, and we're left with liters of H2O. And if we use our calculator, we find out that that's 224 liters of H2O are produced. And that's the answer for 2B. And now you have enough information to answer question 2C and most of the other questions on this worksheet. But one last reminder, this worksheet for gas stoichiometry might also contain some problems that start with a different given. And so use the stoichiometry map. Use the map to try to figure out what are you starting with and what are you looking for. For example, in question number 4, we start with liters, and what we're looking for, it says how many grams. And so if we're looking for grams at the end, there's a different series of steps that you use. But the map will continue to help you. In question 4, you start with liters of gas and convert those to moles. That's step 1. Use the GMV. In step 2, you still use the mole ratio to convert from moles of that given to moles of what you're looking for. And finally, moles of what you're looking for using the molar mass of that substance to convert from moles to grams. And that would be this 3rd step for question number 4. Use this map to try to figure out what are you starting with? What are you given? This is the given side. And what are you looking for? This is what you're looking for. And use this map to try to figure out what steps you're going to need. Not all of them start with liters, and you're looking for liters. Some of them start with grams, and you're looking for liters. Some of them start with liters, and you're looking for grams. Just use this map to try to figure it out.